Hello, my name is Merna, and today I'll be presenting an analyzing of the research article titled Prediction of New Active Case of COVID-19 Using Multiple Linear Regression. The study authored by Smita Rath and Alok Rajan was published in the Diabetes and Metabolism and Clinical Research and Reviews Journal in 2020. The paper explored the use of multiple linear regression models to predict daily activity, COVID-19 case in India, and the state of Odisha. Let's dive into the detail. The aimed to predict the number of new active COVID-19 cases by analyzing daily statistics from India and Odisha. The researchers collected data from WHO and Indian COVID-19 tracking website, covering the period from March 22 to July 4, 2020. They examined variables included confirmed cases, inactive cases, recovered cases, and the disease cases to understand their correlation and impact on daily activity cases. By analyzing the data, they hoped to develop an actual prediction model that could assist in public health decision making and research allocation during the pandemic. To build their prediction model, the researchers first performed data cleaning to remove any missing values. They then used Python for correlation, analyzing, and modeling. They applied two types of regressions models. Linear regression, which is LR, which considered only one independent variable, the number of daily positive cases. Multiple linear regression, which include multiple independent variables such as positive case, recovered cases, and disease case. They split the data into 80% training and 20% testing sets. The models were evaluated using R2 score and error material like mean absolute error and root mean square error to assess their article and reliability. The types of analyzing. The study compared the performing of the linear regression and multiple regression models. Linear regression showed an R2 of 0.9955 for Odisha and 0.9748 for India, indicating a strong prediction model. Multiple linear regression achieved even higher accurate with R2 value of 0.9985 for Odisha and an impressive 1.0 for India. This comparison clearly showed that the MLR model outperformed the RL model due to its ability to account for multiple influencing factors capable complex interaction among variables. Those high R2 values suggested the model's effectiveness in predicting future active cases with remarkable accuracy. The result in conclusion. The result realized some key prediction. For Odisha, the model forecasted 9,358 active cases by mid-August. For India, the prediction was 52,290 active cases for the same period. Those predictions were made using the MLR model, which demonstrated high accuracy due to its R2 value of 1.0. This indicates a near perfect fit with historical data. This study concludes the MLR and is an effective tool for pandemic modeling, offering critical insight for public health planning and decision making. However, it also highlights the needs for continued monitoring and updating of the model as a new variable such as vaccination rates or public behavior change could significantly impact the case number. Critical analyzing. This study has several strengths. It demonstrates high predictive accuracy by using multiple influencing variables. It provides a comprehensive comparison of LR and MLR models, showcasing the importance of multiple diagnostics, analyzing how some limits were observed. The R2 value of 1.0 raised concern about parental overfitting, which could limit the model effectiveness for future prediction. The study relied on historical data and did not account for external factors like lockdown measure, vaccination rate, or behavioral change. To improve accuracy and adaptability, future research could incorporate additional variables such as mobility patterns, diagnostic data, or vaccination rates. Additionally, comparing MLR with more advanced machine learning models like random forecast of neural networks would be valuable to understand their predictive power and limitation. I chose this article because of its potential relevance in pandemic forecasting and its application of multiple linear regression models, which aligns with my interest in regression analyzing. The study provides insightful comparison between linear and multiple linear regression models, enhance my understanding of their real-world application. I found the model's high prediction accurate, but it's also raised questions about parental overfitting and its ability to other region or pandemic. I also wonder how the model would perform during inflection pandemic phase, such as sudden triggers or declines in case. This article inspired me to explore future how additional variables like vaccination rates or mobility patterns could enhance prediction accuracy. Overall, it highlights the importance of using comparison data analyzing and public health and the parental of prediction monitoring for effective pandemic management. Let's close this slide. To summarize, this study effectively demonstrates the power of multiple linear regression models in predicting COVID-19 case, achieving remarkable accuracy with an R2 value of 10 point. It's highlighted the importance of considering multiple influencing factors for accurate prediction, while also raising an important question about parental overfitting and model adaptability. The researchers provided valuable insight into epidemic monitoring, the needs for continued and updating of predictive models. I hope you found this presentation insightful and informative. Thank you for your attention.